The next thing we're going to look at is trig functions for special angles. And the special angles that we talk about in this class are 30 degrees, 60 degrees, and 45 degrees. And they're special because we can set up specific triangles that give us these angles. So we're going to start with an equilateral triangle. That means it's got the same side length on each side. And to make this easier, we're making each side of this triangle equal to 2 units. What we can do with that is just split it in half, and that gives us 2 right triangles. Each one is the same. When we split this in half, that tells us that each half of this side is 1. So this gives us a right triangle with one side that's 1, a hypotenuse of 2, and then we still need to find what that third side is. We can use the fact that this is a right triangle, so we have the Pythagorean Theorem. That would give us x squared plus 1 squared equals 2 squared. And we're just going to solve this for x. So if we subtract 1 from each side, that gives us x squared equals 3. Since we're talking about a triangle, it has to have a positive side length. So when we solve this, we're taking the positive square root of each side, and we get x equals the square root of 3. Now what that gives us is a 60 degree angle here, a 30 degree angle here, and this is a 90 degree angle, so we have a right triangle. That means we can find the function values for sine, cosine, tangent, and the other 3 just based on our side lengths. Let's look at the 30 degree angle. The opposite side is 1. The adjacent side is the square root of 3. And the hypotenuse is 2. So we can find the values of all of our trig functions, and I'm going to find those and use them to fill in the table down here. So our sine would be opposite over hypotenuse, which would be 1/2. So we're filling this in for the 30 degrees. Our cosine would be adjacent over hypotenuse, which is the square root of 3 over 2. And then tangent is opposite over adjacent, so that is 1 over the square root of 3. If we wanted to rationalize the denominator, that would end up being the square root of 3 over 3. And then for these 3, we could just take these and flip them over. So cotangent, if we flip this over, that would just be the square root of 3. Secant would be 2 over the square root of 3, which if we rationalize the denominator, we get 2 times the square root of 3 over 3, and cosecant would be 2. So that's for the 30 degree angle. If we go back up to the 60 degree angle, that's going to flip our opposite and adjacent sides. So for the 60 degree angle, our opposite side would be the square root of 3. Our adjacent side would be the 1. And our hypotenuse would still be the 2. So then we can fill in the values for the 60 degree angle. And we can also do this by using our cofunctions. So we know 30 and 60 degrees are complementary angles, so that means the sine and cosine are going to switch. The tangent and the cotangent are going to switch. And the secant and the cosecant are going to switch. Now let's look at another special angle, and that is 45 degrees. And this one we can look at an isosceles triangle. So we have the same side length for our 2 legs of the triangle, and both of these angles are equal to 45 degrees, and of course this is a 90 degree angle. We could find the length of this third side, which is our hypotenuse. Since this is a right triangle, we're still using the Pythagorean Theorem, so we've got 1 squared plus 1 squared equals r squared. So we end up with 2 equals r squared. Since this is a triangle, we just want positive values for the distances. So we're taking the positive square root of each side, which gives us the square root of 2 for the r. That's going to be the value for our hypotenuse for this triangle. So if we're talking about a 45-degree angle, it doesn't matter which angle we look at since they're both the same. So the opposite side in this triangle is 1. The adjacent side is also 1. And the hypotenuse is the square root of 2. We can use those three things to fill in our table for 45 degrees. So sine is opposite over hypotenuse. If we rewrite 1 over the square root of 2 with a rationalized denominator, it's the square root of 2 over 2. Cosine would also be 1 over the square root of 2. So both sine and cosine have the same value at 45 degrees. Tangent is opposite over adjacent, which would be 1 over 1. So that just turns out to be 1. And then we can do our 3 reciprocal functions. So cotangent would be 1. Secant would be, if we flip this over, it would be the square root of 2. And cosecant would also be the square root of 2. Now to finish this table, we also have the 0 degrees and the 90 degrees. These ones are the quadrantal angles. So at 0 degrees, sine is 0, cosine is 1. Tangent is sine over cosine, so that's 0. Cotangent would be 1 over 0, so that's undefined. Secant would be the reciprocal of cosine, so that's 1. Cosecant is the reciprocal of sine, so that's undefined. We can also do this for 90 degrees. So the sine of 90 degrees is 1, the cosine is 0. Tangent is sine over cosine, so that would be undefined. Cotangent is cosine over sine, so that would be 0. Secant is the reciprocal of cosine, so that would be undefined. Cosecant is the reciprocal of sine, so that would be 1. Now, if you want to try and memorize this whole table, good luck. I really like to give you as many memory tricks as I can, so I have a memory trick for this one. And this just involves sine and cosine. If you can figure out sine and cosine for these 5 angles, you can always get the other 4 just by using either the quotient identities or the reciprocal identities. So really all we need to know is sine and cosine. So here's the trick. If we take the sines for these 5 angles and we're going to rewrite them so they all are kind of in the same form. We want to rewrite them so they all have a denominator of 2, and we're going to use a square root on the top. So 0, we could write that as the square root of 0 over 2. And of course that simplifies to just 0. 1/2 we could rewrite as the square root of 1 over 2. That simplifies to 1/2. For 45 degrees, it's the square root of 2 over 2, which that doesn't simplify. For 60 degrees, it's the square root of 3 over 2. For 90 degrees, it's 1. We could rewrite that as the square root of 4 over 2, and if we simplify that, we get 1. So if you just remember how this works, we've got the square root on the top, a 2 on the bottom, and the square roots go from 0 up to 4. Cosine does exactly the same thing, only in the opposite order. So this one starts out with 1, which is the square root of 4 over 2, and then we've got the square root of 3 over 2, the square root of 2 over 2, and then the square root of 1 over 2, which simplifies to 1/2, and the square root of 0 over 2, which simplifies to 0. So if you can remember how this works, this one, sine goes up from 0 to 4, cosine goes down from 4 down to 0. That's a really quick memory trick so that you don't have to try and remember that entire table. All right, let's find each one of these 3 function values just using that memory trick and some identities if we need to. So for cosecant of 60 degrees, first let's think about which of our 3 main functions this is related to. This is the reciprocal of sine. So if we can find sine of 60 degrees, then all we have to do is flip it over to get cosecant. So sine of 60 degrees, looking at our little table up here, is the square root of 3 over 2. For cosecant, we're going to take and flip that over. And if we want to rationalize the denominator, we're going to get 2 times the square root of 3 over 3. Then for tangent of 45 degrees, if we're only using sine and cosine, then we need to use one of those quotient identities. So the tangent of 45 degrees is the same as sine of 45 degrees over cosine of 45 degrees. Tangent is sine over cosine. So we're just looking at this. Our sine and our cosine for 45 degrees are both the square root of 2 over 2. They're both the same. So if we simplify this, since we're dividing this by itself, we're going to end up with 1. And then last of all, if we want to use the secant of 0, secant is the reciprocal of cosine, so let's find the cosine of 0 degrees first. Oops. Looking at our table, the cosine of 0 is 1. So the secant of 0 degrees would be the reciprocal of that, which also turns out to be 1.